a short recording that I wanted to create, okay, because we need to make sure that you are prepared to understand how multiple choice questions are made and what we do to create them, so you're prepared to answer any of them. Okay, it's very common that we study, we dedicate a lot of time, and then we don't obtain the results that we expected simply because we don't understand the structure of the multiple choice question. Okay, I'm gonna show you some of the questions that we had in the quiz, the ones that some students challenged. Okay, so you have an idea of what we do after we receive these challenges. And let me tell you, it is very difficult for us to make these every time. Okay, we are doing this as an exception because we weren't in contact during the past 2 weeks. And this is something that we not normally do. One of the reasons is that we have to protect the integrity of the exams. Creating a multiple choice question is something that is not easy. Creating a question from scratch takes about 10 to 15 minutes and then requires modifying the questions every year to try to make it better. Okay, so we are not normally streaming, recording the questions. For example, these questions that I'm using today are questions that we are not going to be able to use anymore. Okay, we have to create new questions that will test the different things that we are testing here. So let's start with the first question here. Okay, we have a question that says, which of the following terms best describes the exchange of two ions using the same cell membrane transporter? Okay, this is a question that is looking for definitions. Okay, notice that we receive the percentage of respondents that selected the items. In this case, the correct answer was selected by 51% of the students. And when we have this type of responses in which we have 38% of the students, which is a very important amount, proportion, choosing another different answer, then we have to say, oh my goodness, only 51% answer correctly. Is this a good question? Is this a bad question? Is there anything we have to do about this question? In that case, we go to the discrimination index. Okay, every discrimination index above 0.25 is considered good. That tells you that the students that performed better, the top 33% of the class, chose the correct answer, and the lower 33% chose the incorrect. So it's a good question. So we don't need to modify this question. We don't need to do anything about that. Simply explain to the students how to answer these type of questions and what they have to pay attention to. For example, in this case, exchange. Okay, in the challenges, and I understand that perfectly, some students say, okay, we are talking here about two ions using the same cell membrane transporter, and they say it doesn't specify if they are going in the same direction or in different directions. Well, the word exchange here is the key. If you have an exchange, one thing goes out, you give one, and you take one. Okay, the word exchange means going in different directions. Now let's go to another question here. Which of the following components of the homeostatic regulatory systems determines the set point? Okay, I added some slides at the end. Okay, some students wrote that there is one of the PowerPoints that says that the effector establishes the set point. I was explaining this yesterday in the lecture. Even, I don't remember any of the material that says that, but even if there is a mistake in a book or there is a mistake in a PowerPoint and I see something that like the effector determining the set point, I wouldn't take that as true, okay? Because, for example, let's imagine that we are analyzing the temperature control. Okay, we have the control center, that is the hypothalamus, hypothalamic temperature control center. Hypothalamus receives, monitors directly the temperature of the blood in the brain, blood temperature, and also receives information from sensors in the skin. We are going to talk about that later again. Okay, the hypothalamus contains a center that determines that the body temperature, for example, should be around 97, just to say something. Okay, fluctuating around 97. Okay, once the temperature goes below or above this, okay, the range of normal temperature, then the hypothalamus will signal muscles for shivering, will signal the blood vessels for vasoconstriction, vasodilation, sweat glands, etc. Those are the effectors, saying that the muscles, blood vessels, sweat glands, the skin determine what is the normal temperature of the body. That's not accurate. Okay, so the set point is established by the controller. Okay, the controller, which is part of the control center. Notice that, for example, we are not writing here two of the components of the control center that are the controller and the error detector. Okay, we have only one of the components of the control center. Now that I mentioned that, I may have an idea of where this confusion came from. I know that there is one of the PowerPoint that has the set point very close to the error detector, and the other has the set point saying that the control center establishes the set point. Maybe that brought the confusion, but in any case, controller and error detector are both part of the control center. Okay, so you have to look at one of the components of the control center. And it's good that I realized this now, because I was concerned where in the PowerPoint it says effectors. I was looking at it and I didn't find these effectors establishing the set point. If you find it, please send it to me, because I really didn't find that. And another challenge was saying, one student wrote that the effector acts on the body to establish the set point, but the controller is what signals the effector with the appropriate set point. Well, I think that is a little bit of confusion there. The effector doesn't act on the body to establish the set point. The effector acts following instructions of the control center to re-establish the value of the regulated variable towards the set point, okay, in the opposite direction of the change that stimulated, okay, or set in to work that homeostatic mechanism. Let's go to the next, and of course this question, even though you see all of this distribution of the answers, notice that it has a very good discrimination index. Okay, more than 0.25 is good. Okay, so there is nothing that we need to do about this? Simply because none of the other options are possible. For example, if there was controller and another option was error detector, well, we would consider giving credit for these two, okay, error detector and controller, because both are part of the control center. And I realize now that there may be not a mistake, but simply the set point is placed in different parts when talking about this topic. But error detector is not one of the options here. Let's take a look at this. Discrimination is 0.29, is good. Okay, so which of the following does not fit in the definition of homeostasis? Notice that more than 50% of the class answered correctly, okay, and has a good discrimination index, so most of the students in the top 33% of the class are here, answered this correctly. Now, hormone levels regulation, skin temperature regulation, core body temperature regulation, blood pressure regulation. So I see that there is no problem with these two. Almost everybody knows that core body temperature and blood pressure regulation fit the homeostasis definition. Now, why there were problems? 40% of the class didn't answer this correctly. Let's take a look at the challenges. In the PowerPoint, one student writes examples of non-homeostatic conditions given in the PowerPoint, for example, menstrual cycle, pregnancy. And when speaking of core body temperature regulation, the sensor of the skin detecting cold air would cause vasoconstriction, create goosebumps, and induce shivering, okay, even though the core body temperature has not changed. Therefore, skin temperature regulation was an example of feed-forward or anticipatory feedback. Well, all that is true, but let's take a look at what happens here. What is the definition of homeostasis? The controller has a set point, 96. Okay? When there is a variation, if there is a variation, what the control center does, what the error detector does, there is a difference between the value of the regulated variable and the set point. If there is a difference, the error detector will inform the controller, and the controller will activate the effectors. Okay, there has to be an actual change in what the body is monitoring. Remember, the definition of homeostasis is a set of mechanisms that work together, that are interrelated, okay, that monitor variations in regulated variables, okay, and act when there is a variation, okay, away from a range of normal values that fluctuate around a mean, and start or activate certain mechanisms to regulate, to maintain the extracellular fluid or compartment in steady conditions. So there has to be an actual variation in the extracellular fluid regulated variables. Okay, the core body temperature is a regulated variable. The skin temperature is not a regulated variable. Okay, so that's why this is the correct answer. Okay, and we mentioned in the PowerPoint that feed-forward feedback is not homeostatic. These mechanisms are great. They save energy. They prevent variations, but they are not homeostatic. Okay, homeostatic mechanisms are only the negative feedback mechanisms. What about hormone levels? Okay, we have many hormones in the body. Most of them are regulated by negative feedback. There are, yes, some exceptions. For example, during ovulation, that we have a positive feedback. The actions of some hormones during delivery, yeah, those are exceptions. Okay, but most of the hormones in the body are regulated by negative feedback. Okay, so it's very important, and this is just the start. In every quiz, in every exam, okay, in the questions there will be two answers, at least two answers that seem likely. Okay, this is likely because I remember that ovulation, this delivery, etc., was an example of a positive feedback. But which is better, the exception to the regulation of the hormones or the skin temperature? This is something that our body is not monitoring. Okay, it's simply the regulated variables are core body temperature, blood pressure, okay, pH, oxygen, CO2. You have a list of regulated variables at the end of that PowerPoint. So you have two answers that may be likely. For me, this is not likely at all, but there could be two answers that are likely. But there is always one that is the most likely. Okay, for example, if I see this quiz, I would, okay, oh my goodness, skin temperature, core body temperature. These two could be likely for me. I have to choose one. Well, I know for sure that core body temperature is a regulated variable. It's very important. It's vital. So I will choose skin temperature as the incorrect. Okay, but hormone levels regulation is something that we study since we started studying anatomy for the first time as examples of homeostasis, as examples of negative feedback regulation. Of course, some exceptions exist to confirm the rule. Let's go to the next. Okay, this is which of the following physiologic processes will most likely require a second messenger? Good discrimination index, 0.6. Notice that 78% answered correctly. I put this here to try to understand one of the comments of a student. Which of the following physiologic processes will most likely require a second messenger? Student writes, second messengers are typically seen in G protein coupled receptors and enzyme linked receptors. Steroid intracellular receptors will only use secondary messengers if they become bound to plasma membrane. And ionic or nicotinic receptors do not use secondary messengers. Oxygen and CO2 typically use simple diffusion and do not use channel transports. Well, let's take a look at the answer given by the second more frequent group of students. 8 students will most likely require a second messenger. Action driven by lipid soluble hormones. Well, this is a question that is simple. Okay, water soluble hormones cannot pass through the cell membrane freely. Okay, lipid soluble hormones pass freely. Okay, so they don't need a second messenger. So which of the following will most likely require water soluble hormones? Oxygen, CO2 diffusion, as this student wrote. I really don't understand I don't think this is probably a challenge. This is probably a student writing comments to then answer the question. I don't know. I think this should be clear for everyone. Okay, lipid soluble pass freely, so they don't need a second messenger. Water soluble are not soluble in lipids, so they need to bind to extracellular receptors and activate a second messenger to do their action. And here we have another. Oh, it's the same. I put it twice. Oh. Then we have another here. Which of the following is the most abundant cation in the cytoplasm? This is something, this wasn't challenged by anyone, but I was curious about this because this is a basic, a concept in physiology. We have the intracellular compartment, we have the extracellular compartment. Sodium chloride is the most abundant thing out here. Potassium is the most abundant cation here. We have also some bicarbonate here, more bicarbonate than inside. So most students chose the correct answer, almost 80%, 78%, 35 students. Cation, positive charge in the cytoplasm. 9 students chose sodium, which is the most abundant cation in the extracellular compartment. 1 student chose bicarb, which is an anion, first of all, and is not the most abundant. Even the most abundant anion in the cytoplasm is in the extracellular compartment. Why this happened? Why some students chose sodium? I'm not sure. This question had a discrimination index of 0.63. Excellent, more than excellent. Maybe these students were expecting intracellular and they didn't find the word intracellular compartment or within cells and they found cytoplasm. This is something that is concerning for me. If some students are not able to answer questions, if they don't see exactly the same thing that the PowerPoint says, please, it's important that you realize that a PowerPoint is not a study tool. The PowerPoint is simply a guide for the professor, so we don't forget to teach about everything that we wanted to teach. Studying using a PowerPoint is something that many people do, but I have to tell you that's not something that we should be doing, because you are studying something that is not for getting credits to enter into a university. You are already in the university, and what you are studying here are things that you are going to be using for all of your life. So you need to study in a way that develops good study skills, learning skills, and that guarantee that you retain all this forever. I don't like judging people. I don't like telling students that they are doing is wrong, because I know that criticism is sometimes not well accepted. But please take this as an advice, of someone who's been a student for so many years and has had so many bad experiences in the past, that simply is trying to prevent that you go through the same bad experiences. I feel sometimes sad when a student tells me, oh, I think this is not the correct answer because the PowerPoint says that. Gives me goosebumps, and there is no hard feelings. There is nothing bad or personal with that specific student, but I simply feel worried about this. If I see something in the PowerPoint that is not clear, oh my goodness, let me see this. Let me go to the book. Let me find some other information in a video maybe. Okay, and if I don't have it clear at the end, let me ask the professor. Professor, why it says here that the effector establishes the set point, and here it says that the controller or control center establishes the set point. Okay, so I hope this video helps. Okay, if you have any other questions, please email me. Okay, and try to study not the day before the exam. Please study all the time, every day a little bit. Thank you so much.